Okay, good morning, everyone. My name is John Davidge. I'm a software engineer at Cisco working on OpenStack. And today I'm going to be talking about IPv6 Prefix Delegation, what we've merged into Liberty, and maybe touching on some future extensions for it going forward. So what's gone into Liberty this cycle? This is something we've been working on for the last almost 12 months or so, I'd say. And in Liberty, what we've managed to get in is prefix delegation support for automatic assignment of subnets to your tenants. So with this feature enabled, when your tenants create an IPv6 subnet, they no longer need to provide a CIDR. You as the administrator no longer need to create a default IPv6 subnet pool. All the tenant does is they issue their subnet create request. They tell it that they want it to be IPv6. And with the prefix delegation mechanism enabled, it goes ahead and handles all of that. So what it does is Neutron's now able to communicate with an externally managed prefix delegation server. Now this can be any DHCP v6 server, hardware or software, as long as it's reachable by your Neutron network nodes. And as the OpenStack administrator, you need to first configure that external prefix delegation server with the prefix pool that you want to hand out. And if you want it to take care of all the routing automatically for you as well, then you need to configure it to do that. So what does this look like as a network diagram? So this is a network diagram put together by Robert Lee, my colleague at Cisco, who is my co-author on these patches. And what's new in this diagram, which will probably look familiar to some of you, is in the Neutron router namespace on the network node, you can see that we're spinning up one or more Dibbler clients. Now, Dibbler is an open source DHCP v6 client server package. And we're using the client for the reference implementation of the DHCP v6 driver in Neutron. It's been built with a pluggable architecture, thanks to Sam Betts at Cisco. So if someone wants to come along and implement a new driver for a different DHCP v6 client, that can be done. So every time your tenant creates an IPv6 subnet that they want to be controlled by prefix delegation, and importantly, adds an interface to a router with a connection on the external network, we spin up a new instance of the Dibbler client, and that Dibbler client is responsible with talking to your external DHCP v6 server and handling all of the prefix delegation traffic. So what does that prefix delegation traffic look like? It looks like this. I'll just dive into this very quickly. So essentially, what this is showing is the flow between Neutron, the Dibbler client, and your DHCP v6 server. So when the subnet's created, initially when the subnet is created, nothing much happens. The subnet is given a dummy prefix, nothing happens just yet. When the router interface is added, however, as part of the router update that goes to the L3 agent will recognize that that's a router interface for a prefix delegation enabled subnet that hasn't yet been given a prefix, and will spin up a new instance of the prefix delegation client with that PD enable call you see there. The Dibbler client then communicates back and forth with the external DHCP v6 server. Assuming all goes to plan, it receives a prefix which is finally assigned to it in the reply that comes back. And the Dibbler client then communicates back to your Neutron server using the SIGUP mechanism, which tells the agent, hey, I've got a prefix, I've stored it away in a file somewhere, and I want you to go and retrieve it. So the L3 agent then opens up that file, retrieves the new prefix, it knows which subnet it belongs to, and it calls off a new prefix update process back to the Neutron server, which updates the subnet, the router, and all of the instances connected to that subnet. So let's see a demo. I'm not going to risk a live demo in a 10-minute time slot, so here's one I made earlier. The first one I'm going to show is, so this is how you enable it. So in your neutron.conf file, which I'm just going to pause very quickly there, there's already a mechanism as part of the Subnet Pools mechanism, which went into the Kilo release, for defining a default subnet pool for both IPv4 and IPv6. We leverage that for prefix delegation in Liberty. So if you want to enable prefix delegation, you set your default IPv6 subnet pool to prefix delegation. What that does mean is that this also overrides and replaces the behavior of the default IPv6 subnet pool. So you can't use both at the same time. So once that's configured, you then also need to make sure that your DHCP6 server is set up to actually hand out the prefixes that you want to. For the purposes of this demo, I'm running it all on a single node DevStack, and I'm using Dibbler as well as the server, but you can use any prefix delegation compliant DHCP6 server. So at the bottom of the configuration file here, you can see that I've told it to listen on the correct interface. It's configured with a /60 pool, which is an actual reserved pool in the data center where this is running, which is going to allow all the delegated prefixes to be globally unique and routable. So there I'm starting up the Dibbler server. The logs are going to stay there the whole time, so you can see what that's doing as well as what Neutron's doing. And right now you can see it's not doing anything because Neutron hasn't talked to it yet. So the first step is to create a Neutron network. So off it goes, Neutron network. And then a Neutron subnet. You can see I'm giving it a name, I'm telling it the correct address and array modes, and I'm telling it to use IPv6, but I'm not telling it anything special about prefix delegation. Neutron just knows it needs to use prefix delegation in this case. You can see the CIDR it's given is a dummy empty CIDR because it hasn't been given a real prefix yet. And something that's actually missing from this demo is the subnet pool ID here is blank. In the latest version of the code that's in Liberty, the subnet pool ID will actually show prefix delegation so that you as the admin and all your users know that that subnet's prefix delegation enabled. So next in the demo, we're going to go ahead and open up Horizon, I believe, and just show what all this looks like to your users in Horizon. So if we go ahead and fire up an instance on that subnet, you'll be able to see that the instance is able to boot correctly. It's given an address, but it's given an address from that empty dummy prefix. So it can't do much with it yet. It's certainly not going to be able to communicate with the outside world, but it starts, it doesn't fall over, and it's just waiting until your subnet is updated with a real prefix. So there you can see IP address from the empty subnet. So why has it got an address from the empty subnet? Well, it's because the prefix delegation process itself won't actually start until you add a router interface between your prefix delegation enabled subnet and the external network. So I'm going to go ahead and add this router interface. This router already has an interface on the external network. And if you keep your eye on the Dibbler server logs on the right-hand side, you'll be able to see that within a couple of seconds, it receives a whole bunch of communication. There it goes. So that's the communication that's going back and forth between it and the Dibbler client that Neutron's spinning up for that server. So you can see there, it's decided on a /64 to hand out. It has to be configured to hand out /64s because that's all we support in Neutron right now for IPv6. And refreshing that page, you can see that the router interface has been updated with an IP from that prefix. The subnet itself, that's the CIDR that matches the prefix delegated by the server. And if we go to the list of instances, we can see that the instance also has been updated with a new address from the appropriate prefix. And then if we go ahead and fire up the console for this server, we can demonstrate that all of the routing to get that traffic out of your data center is also handed off to the prefix delegation server. So as long as you've configured that correctly, all of your routing's taken care of. We have no concept of floating IP in IPv6 and Neutron. So as long as your security groups are set up so that traffic is free to move in and out, you can see here I'm pinging, in this case, Google DNS over IPv6, and the pings are coming back and forth, no problem. So that, without any effort really from the user, they're able to fire up an instance, get an address, and talk to the outside world without any special knowledge of what's going on in your data center. So what does this look like in reverse? Well, if we go ahead and delete that router interface, you can see on the right-hand side there, we got some more server logs from the prefix delegation server. And that's because when you delete the router interface, the Dibbler client is told to release its prefix. update Neutron to tell it that the prefix has been released, and then shut down because we don't need it to be running anymore. So you can see the server there has gone back to the dummy empty prefix. That instance has again been given an address from the empty prefix. And if we then open up the console again and try to ping out to Google once more, you'll be able to see that it's no longer able to connect to the internet because that route has been destroyed. So that's just about it for the demo. Let's move on to the next slide. So I think that's just about my time. I don't think we've got any time for questions. But if you've got any questions, feel free to ping me on IRC or tweet at me. I'll post a link to these slides and a link to the video up on the schedule later today. Thank you.